What the study says.
Imagine sitting down to eat a massive, incredibly satisfying hamburger. You finish the last bite, you feel completely stuffed, but your body only absorbs half the calories. Why? Because half of that burger patty was actually made of a flavorless, non-digestible plastic powder. Welcome back to What the Study Says. I'm Dr. Kai.
And I'm Dr. May. Today we are diving into the 2025 Ig Nobel Prize for Chemistry. That is the satirical award that honors research that first makes you laugh and then makes you think.
Right, and this year's winner is a perfect example of that. It highlights experiments testing whether eating Teflon, basically a form of plastic formerly called polytetrafluoroethylene, is a good way to increase food volume and satiety without increasing calorie content.
It is a completely wild concept that forces you to really rethink what we consider edible. For this deep dive, we're pulling from a 2018 U.S. patent and a 2016 article from the Journal of Diabetes Science and Technology to try and understand the science and the safety behind this.
Because the core problem is that humans rely heavily on gastric distension to feel full, the physical stretching of the stomach. We have zero-calorie drinks figured out, sure, but engineering a zero-calorie solid food without ruining the meal is a much harder puzzle.
Exactly. I mean, right now, if you want to bulk up food without adding calories, you are usually looking at dietary fiber or bulking agents like xanthan gum. The limitation there is they drastically alter the taste and texture of your meal.
And if you consume them in high volumes, they draw in water and cause severe digestive issues. You cannot just replace half your dinner with fiber and expect to function normally the next day.
Yeah, you really can't. But the alternative this patent suggests feels almost like science fiction. They propose using raw, virgin PTFE, basically Teflon, as a direct ingredient by mixing the powder right into your food.
And the ratios they propose are staggering. I mean, we are talking about 3 parts food to 1 part plastic, or even a 1-to-1 ratio.
Which sounds inherently dangerous on its face. But from a purely chemical standpoint, PTFE is uniquely suited for this application. It is widely considered the most chemically inert material known to science.
So it just doesn't react with other compounds in the body at all?
Right. It's completely flavorless, and physically it's quite soft, so it won't scratch your gastrointestinal tract. Furthermore, it's highly resistant to both stomach acid and cooking heat. You could mix it into raw ground beef, throw that burger on a grill, and the plastic remains perfectly stable.
My first thought reading this, though, was toxicity. What actually happens when you ingest industrial plastic in those massive quantities?
Yeah.
Surely the body reacts in some way.
Well, that is the most surprising part of the historical safety data they cite. Back in the 1960s, researchers ran studies where rats were fed a diet consisting of 25% PTFE for 90 days.
25% of their entire diet was plastic.
Yeah. Yes. And the rats lost weight, exactly as you would expect when diluting their caloric intake, but they showed absolutely zero signs of toxicity. The mechanics behind that come down to its massive molecular weight and its insolubility.
So when you ingest it, it physically cannot cross the intestinal wall into your bloodstream.
Exactly. Your body can't break it down or absorb it, so it simply passes right through you.
Passing right through you sounds fine in theory, but wouldn't flushing massive amounts of Teflon down the toilet just create an unprecedented microplastic nightmare for the environment?
That was my exact concern when I first read it. But the patent actually accounts for that through some pretty brilliant environmental engineering. It recommends a highly specific particle size of 130 micrometers.
Which serves a dual purpose, right? It guarantees the particles are too large for the human body to accidentally absorb.
Right, and secondly, it ensures that when it's eventually flushed away, the plastic is heavy and large enough to settle out in the sludge at wastewater treatment plants, rather than floating away into the ocean.
So instead of polluting the ocean, it gets filtered out and sent to a landfill, meaning, theoretically, future sanitation workers could be mining human waste at the city dump for highly valuable recycled Teflon.
As absurd as it sounds to mine wastewater sludge for non-stick pan material, yes, that is practically what the patent envisions. It creates a complete closed-loop system for the plastic.
What this all means for you, looking at the bigger picture, is just how complex the obesity epidemic really is. The biological drive to feel physical fullness is so powerful that science is literally engineering ways to trick your stomach's stretch receptors using the exact same inert materials we already trust in surgical implants.
Which leaves us with a really interesting philosophical question. If we can successfully and safely separate the physical, comforting sensation of a heavy meal from the actual caloric intake by using synthetic materials, will the gourmet dining of the future become mostly an engineered physical illusion rather than actual food?
That is definitely something to think about next time you feel completely stuffed after a big dinner. To summarize, adding inert plastics like Teflon to our food might actually be a scientifically viable way to increase satiety without adding calories, assuming we can get past the mental hurdle of eating it. Thank you for joining us on this deep dive. If you enjoyed this conversation, please subscribe to the channel and share this with your friends.